Before you can understand the Newman projection, you first have to understand the line angle structure. If you don't know what I'm drawing right now, you need to go back and do your homework before you come to my channel. So, the line angle here is the classic textbook example of a N-butane straight chain 4 carbon. 1, 2, 3, 4. You should know by now that the carbon 2 and the carbon 3 each have the 2 hydrogen, and if you draw them in, one on the wedge bond coming out at you like the James Bond, and then one hydrogen on the dash bond going away from you like a coward. Now, if we want to draw this in the Newman projection, you first need to understand what you just draw. You draw a line angle on 2-dimensional paper. Well, this the tablet, we got technology, right? So this 2-dimensional, right? And the Newman projection, you have to sight down a bond. You have to look this way. If we want to sight down the C2 to C3 bond, we have to turn the molecule, turn the paper, or turn your tablet 90 degrees so you can sight down the C2 to C3. Now, this here we draw the actual Newman projection looking down C2 to C3. The intersection of these three lines over here, that will be the front carbon. In this case, it's C2 because we sight down carbon 2 to carbon 3. Front carbon is C2, and then the circle in the back is carbon 3 because we sight down C2 to C3. If you cannot see this in your brain, you need to build a goddamn 3D model with the model kit. Students always ask me, hey professor, how you know? Because when I was your age, I built a model, and you should build a goddamn model too. Stop being lazy, my god. Now, if you have the model, the 3D model in front of you, you should be able to tell where the atoms are located on the Newman with no ambiguity. The more you practice, the more you can see in your brain. Now, the hydrogen on the dash bond, the coward going away from you, must be on the left, and then the wedge hydrogen coming at you must be on the right-hand side of the Newman projection. Again, look at the 3D model and you see exactly what I'm talking about. And then you have the carbon 1 pointed down to the carbon 2, and then you have the carbon 4 pointed up to the carbon 3. Make sure you number your carbon. My god, I always tell my students to number the carbon when you do something like this, but my god, they never listen to me. Now at this point you may be asking, who even is Newman? And I tell you, this very important, going to be on the test, so pay close attention. Students always ask me, who is Newman? Now I tell you, who the hell care who is Newman? He didn't discover the calculus, he don't know the One Piece, he not the Newton, not the Newgate. Who the hell care about Newman? My god, stop asking. Now, students always ask me how you know which conformation of the Newman, because the Newman bond can rotate, right? How you know? So here's just a very simple example. Hexane 6 carbon straight chain. If you look down the carbon 2 to carbon 3, I even color code it for you because I'm nice. If where the bond connect is pointing up like the carbon 2, I call this the hammer conformation. If the bond connect pointed down like the carbon 3, I call this the Ginyu conformation. If you are too young to understand the reference, go look it up for your homework. Now, on the carbon 3, you also have the carbon 4, carbon 5, carbon 6, this propyl group. You just draw the propyl group on the Newman. And then, of course, you still have the carbon 1 coming down on the carbon 2. Very simple, right? Now we have been doing the line angle to the Newman, so some of you may ask how to do the Newman back to the line angle, and I tell you, just build the goddamn model. My god, you look at the model, turn the model 90 degrees, that is how you go back and forth between the Newman and the line angle. It's the same thing. I don't have time to draw again for you. My god, you build the model yourself. Now let's do a slightly more difficult example to show how to draw the Newman from the line angle. This is a slightly larger molecule but same idea. Make sure you number your carbon always. I always tell the student to number the carbon. If you don't know your nomenclature by now, if you don't know how to number this molecule, you need to go back and do your homework before you come here. Now let's look down the carbon 3 to carbon 4. So instead of looking left to right like how we do in the previous example, now we have to look from the right to the left because this molecule is numbered from the right to the left to be consistent with the IUPAC numbering. Again, if you don't know your IUPAC, go do your homework. The carbon 3 with the chlorine, it's the pointed upward, so that is the hammer conformation. If you forget the hammer conformation, flashback 1 minute. And then the carbon 4, the cyclopentyl, that is the Ginyu conformation. Now, if you build a model, you look at the model down carbon 3, carbon 4, you can tell right away that the wedge chlorine coming out at you from the line angle in the Newman must be on the left hand side, and then the dash hydrogen, I draw it for you because I'm nice, it must be on the right hand side in the Newman. Same idea for the cyclopentyl on carbon 4, it is on the left hand side in the Newman if it is wedged on the line angle, and then you have that dash hydrogen on C4. The Newman, you can always number the front carbon and the back carbon right away. Carbon 3, carbon 4, and then on carbon 3 you have the carbon 2, which is the isopropyl substituent, and you can number the carbon 1 as well. Doesn't matter, the two methyl on carbon 2 are equivalent, both are carbon 1. And then you have the back carbon, carbon 4, bonded to the carbon 5 and the carbon 6, the ethyl substituent. Very simple, carbon 5, carbon 6 pointing up, just like that. Holy shit, I made a mistake and you guys don't even tell me what you doing. My god, we not looking down carbon 2, carbon 3, we look down the carbon 3 to carbon 4 like this. My god, the other day during class, I made a mistake on purpose when I talking to the class and nobody tell me. And then at the end of class, I announce that if someone catch my mistake, I give them extra credit, 2 points, and then everyone raised their hand. My god.